So welcome. My name is Devis Tuia. I am the head of the Environmental Computational Science and Earth Observation Laboratory of EPFL in the Sion campus in Valais. And today I'm your host to talk about space for cities. And in particular, to discuss with you what is the potential of space data to observe urban areas, cities in general, and also see what is the potential impact to a lot of application from planning to renewable energy consumption. So let's get started. When we study cities, we basically observe that it's an important problem because most of the world population nowadays lives in cities, and cities are becoming more and more complex. And like if you look at this image of Tokyo, you can see that there are several different aspects at work. Let it be human mobility, transportation, the organization of the planning of the built environment, and that all this is very difficult to grasp using only a terrestrial view of the city. And this is not only true for megacities like the one you see in this image. All this complexity can also be observed across geographies. For example, if you compare the image you see on the slide that depict cities of Caracas, Mumbai, and Cape Town, you can see the wonderful diversity that cities are made of, where we have very organized and high-rise type of buildings, like in the example of Caracas on the right, and then more of a organic, strangely organized type of built tissue that we can see on the left side in Caracas. And all this complexity lives side by side and has strong social consequences or reasons. I mean, we could talk about causality, but this is not the topic today. But as you can see, if you get a step back and you observe cities from afar, in our case from space, we can actually start analyzing how cities organize, how they are dynamic, and how the urban tissue organizes in space and also in time. So yeah, space. Space is a prime way of observing cities. So we have all these sensor satellites that are orbiting over our heads in space, and we have many of those of different type and resolution and image quality as well. Some of them you can access for free, for some you need to pay, but all in all, observing cities from space allows us to really describe urban areas in a way that can be global. We can observe the dynamics of urban spaces because we can have time series. Remember, satellites come to the same place at regular intervals. And then we can take also advantage of the fact that different satellites have different resolution, so we can look at very local organization or global organization of the city and understand the usage of urban areas. I will now go through these 4 points and one by one and give you some examples, hoping that this will inspire you to, pursue research or business in one of these areas. So I've talked about being global in observing cities, and as you can imagine, satellites orbit around the Earth, so they observe the different urban areas all over the world at regular intervals. And this allows us to have analysis that can go across several cities. So as you can see on the image on the top, we can have actually a view of the density of urbanization globally thanks to satellites. And this is something that is now available through global products like the Global Urban Footprint, for example. And not only we can see the ensemble of the planet in terms of urbanization, but then we can zoom in, like in the example below of Johannesburg, where actually we can analyze at a very local scale how much of the urban space is actually occupied by impervious surfaces, let it be buildings, asphalt, roads, and the like. And this is information that we could not have before because we didn't have these satellites coming back at regular intervals. And this is crucial information, especially in southern countries. Imagine, planners, peace organization, non-governmental organizations. This information is and must be accessible to everyone. The view of the city we have is not only a point in time. Remember that satellites come back to the same place every 2 weeks, 5 days, every day, depending on the sensor you use. And this allows you to basically monitor how cities evolve in time. You can imagine that as like a heartbeat of a city, where you can basically know how the city moves in space. And as in the example you can see here on the right, where researchers studied the urban expansion in Accra, Ghana, they've used existing products that were able to trace back the growth of Accra from the 80s, and then at a more fine-grained scale when using new generation sensors that helped having a footprint of the city almost every year. And of course, this needs technology to come to these maps of urban growth, but this is basically a potential use of satellite data that you could have if you are a planner and you want to know in almost real time what's going on in a urban area. It's not only about urban footprint themselves, but we can also start working on understanding what is the typologies that are occurring on the city. If you cross different type of images, like the one you see on the top of these slides, you could use at the same time satellite images, height model, maybe information from social media, and night lights information. So all the sensor data that are nowadays available to us, in order to understand locally what is the construct of the city and how the different neighborhoods are being used. As you can see in the map at the bottom, in this study, we were able to characterize at a hectare resolution, which was the density and potential use of every little 100 by 100 meters region in terms of density of the construct, the height, and then we could understand if it was a commercial building district, a residential area of low or high density. And when we have this information, this is basically very useful because we can cross it with all kinds of socioeconomic data. So, for example, the access to education or health facility or statistics about housing. And this allows us to understand the network of cities, in this case in northern Germany, and to see if there are dynamics like cities that are more where people sleep, or cities that is more where people go to work, and then understand fluxes of people, socioeconomic dynamics, and the like. So it's a kind of a door to assess the quality of life that you can see in urban areas. But it's not only about looking from really afar and having very large footprints. We can also look at city at a very fine-grained way. So in this case, we start mostly to consider very high-resolution satellites. They can be metric or submetric, so less than a meter resolution. And there is a number of sensors that provide this type of data. They're usually commercial, but they basically help you zoom in and look at single buildings, for example, and they allow to understand the building geometry, as you can see here in the example on the right, where it was possible to delineate buildings quite precisely, analyzing the aerial image in this case. And or in this example, where colleagues at AXA, they were building models to basically estimate the height of the building from oblique images taken from space. And this is pretty interesting because it's a kind of information that seems very simple to grasp. So if you look at the buildings, you will immediately know how many floors you have. But when you have to scale this up at the level of an entire city and you have to go each building one by one, it's very good to have sensor data that basically allow you to do that automatically with the model. And in this master study, so jointly supervised by AXA and the CV lab of EPFL, well, researchers could estimate the number of floors with a 15% error, which is a pretty interesting result, and also to pinpoint which parts of the image were important for the model to get to the estimation. So you see, this is a typical example on how space data can help you, together with some machine learning, to extract information at scale. But it's not only about geometry. You can also then make the step to usage. And for example, to understand for each building in the city, what is this being used for? So it can be a residential house, but it can also be a shop or a bank, maybe a museum. And in this specific study, we used, together with the space data, also terrestrial images, Google Street View type of images or social media based. They could help us by looking at the facade of the building to basically understand better what the building was used for. Last but not least, I promised you an example in renewable energy, and this is an example provided to us by our colleagues at Picterra. And in this specific study, they were assessing the potential for solar panel to be installed on the roof of the buildings. And using some machine learning models that I won't detail here, and some height information, it was possible to understand for each roof where we could put the solar panels and which location were the most interesting with respect to the solar exposition of the single buildings. So in conclusion, I hope you have appreciated how much space technology is important for observing cities and for the future development, and that you have now an idea on which sensors you can use and what are the interesting applications to observe, monitoring, and plan better cities. Of course, this doesn't limit itself only to the built environment, even though I presented mostly examples about buildings and impervious surfaces, but you can also use all this technology to analyze green spaces and the interaction between the construct and the non-construct spaces. In all this example I presented you today, there was also a heavy involvement of image processing and machine learning techniques. Of course, I didn't detail that today because it was not the topic, but this is also important that you get some training in that, because it will allow you to make really the link between the sensor data and the final product you want to have. But this is another story for another course, and I invite you to continue your journey to better understand cities with space data.